Assalamualaikum warahmatullahi wabarakatuh. Good evening to our sir, Dr. Syahmeh Hayan, DSMC. Welcome to our group presentation video, BDA 34103, Numerical Method, Semester 1, 2022. Our assignment was given, the topic is the eigenvalue and corresponding eigenvector of a translational mechanical system. So this is our group members. Appoint me as a leader of the group.
Assalamualaikum and hello. I'm Numerical previously with measure number 80 200151. I will explain the introduction. So, what is numerical method? Numerical methods are used when analytical procedures like work finding and area under the graph are unable to quickly or possibly solve the mathematical issues associated with the engineering analysis. In this paper, we'll go into greater detail about 3 practical issues that can be resolved numerically. We'll also carry out a case study to demonstrate how the idea of eigenvalue and eigenvector can be used to simplify the calculation of simulation linear equation. MATLAB simulation software will be used to verify this calculation. When evaluated using MATLAB, there is a discrepancy in value due to many values were considered. It is suggested that the calculation be carried out with a higher precision of decimal places in order to ensure that the results obtained are as precise as possible. Finally, this case study demonstrated the significance of using simulation tools such as MATLAB in engineering to validate calculation. This is because failure to complete this task accurately could have catastrophic consequences in the field of engineering, where accuracy and precision are crucial.
Assalamualaikum warahmatullahi wabarakatuh. My name is Natia Aida binti Norizan. So my metric number is 80200029. So I will explain the 3 real-world problem, which is the first is escalator. Is a moving staircase that transport people between the floor of a building or structure. It is made of chain of individual links step on the track that cycle on a pair of tracks that keep the step tree horizontal. Escalator can transport a large number of people, and the escalator method is dependable method for determining the eigenvalue of a matrix with a strong control. Disadvantage of this method is that each step of escalator process connect with the bordering of a matrix by a row and column. The eigenvalue and eigenvector of the resulting intermediate matrix must be determined. This in turn the expenditure of considerable efforts in calculating intermediate results that are not required in the final analysis. In a formula are provided for calculating eigenvalue and eigenvector by bordering by 2 or 3 row column at a time. Second is a plumbing, which is a plumbing refer to any system that transport fluid for a variety of a purpose. To transport fluid, plumbing employ pipe, valve, plumbing fixtures, tank and other device. Plumbing is used for a variety of purpose including heating and cooling, waste removal and portable water delivery. A lift system for disposing of human waste were less sophisticated. Plumbing system advancement was glacial. From the time of the Roman until the 19th century, almost no progress was made. The pressure created in the water supply system and the friction created by the water moving through a pipe are 2 factors that limit both the height to which water can distribute and the maximum flow rate available at any point in the system. The 2-dimensional expansion, depression, reaction equation describe the hydrodynamic process. Although this equation can numerically solve, it is impractical for modeling network dispersion, so the equivalent 1-dimension equation is used. Based on numerical method, a numerical solution for pipe network is proposed. As a result, the large system of equation that represents the discretized network is precisely into three easy to solve tridiagonal system for each pipe and one low order system for concentration pipe conjunction. Fourth is elevator. An elevator or lift is a machine that transports people vertically between floor, level or deck of a building, vessel or other structure using a cable, hydraulic cylinder and roller track. They are typically powered by electric motor that drive traction cable and counterweight system like a hose through some pump hydraulic fluid to raise a cylinder piston similar to a jack. In addition, a vertical motion, some elevator can travel horizontal. The elevator problem can be applied a variety of class. Naturally, the more advanced the class, the more complex solution. If you use a standard content application, a numerical class could focus on developing a simple linear function of 2 variables, whereas a probability class could focus on the problem as an application of eigenvector and eigenvalue.
Next, we move to escalator system analysis, where escalator system analysis is important to identify the formula, the parameter, and the free body diagram to find the eigenvalue and eigenvector. Next, we move to the methodology of escalator system analysis. In this, our group choose to use relative escalator system in concept, which is mainly a subtopic in the eigenvalue and eigenvector to the analysis of the maximum and minimum magnitude of the absolute velocity of the escalator depending on mass and load. The free body diagram shows the accelerator step, load, and step well of accelerator, the angle of types, the kinetic energy of system, and work done by the braking force, work done by frictional force, and last but not least, work done by gravity. The parameter shows the test accelerator, which is the accelerator A, accelerator B, accelerator C with the different load. Alright, we move to the formula in accelerator system analysis. In accelerator system analysis, the formula is important to identify first before we proceed with calculation to find eigenvalue and eigenvector. First of all, we have dW equal to dE equal to 0, where dW is elementary word equal to kinetic energy, theorem dE. So dE equal to differential with time, where bracket I1 multiplied with omega 1 over 2, which is I1 is rotational inertia, omega 1 and omega 2 and omega 3 is angular velocity. For dW equal to mg sine 35 degrees multiplied with v minus m1 multiplied with omega 1 differential with t time. So m1 is the mass of load, g is the gravity, and 35 degrees is the angle of tilt. Next, we move to the kinetic energy. The kinetic energy, the formula is 1 over 2 mv squared plus 1 over 2 I omega squared. So based on the formula and the parameter at the given, we proceed with equation of motion. The equation of motion they have formed is 3. So there are 3 equations of motion. Based on the equation of motion, we can arrange the equation to find and identify the simple equation to form V1, V2, and V3 with dot. That's all from analysis accelerated system. Thank you very much.
Next, I will explain for result. First of all, we have to convert this into metric form. So the V dot equal to negative omega equal to negative V over R. We rearrange it and substitute the value for M1, M2 and M3, which is 300, 800 and 1500 respectively. Also for R1 equal to 0.7, G equal to 9.81 and U1 and U2 is equal to 1. And then we also let V1 squared equal to V1. After we substitute all the value, we will get a difference value which is 0, 26.66750, 0, negative 28.134, 5.33 and 0. We also let 1 over R is equal to lambda. Then we multiply the lambda with the identity until we get the final matrix form. After that, we're going to use Sauer's rule to solve this problem. And then until we get the value for lambda 1, lambda 2 and lambda 3, which is we get lambda 1 is equal to negative 12.249, lambda 2 0 and lambda 3 12.249. As we know, we use lambda is equal to negative 1 over R. Then we're going to calculate the eigenvalue, and then we get for the first one is 0.082, second is 0 meter, and for the third is negative 0.082 meter. After that, we have to derive the equation for V2, and then we get the equation is V2 equal to negative 12.249 minus 50 V3 divided by 26.667. And then for the equation of 2 is 5.33 V2 plus 12.249 V3 equal to 0. Next, we're going to substitute the equation of 1 into 2, and then we're going to get the value for V3, which is 1.088. After getting the value for V3, we're going to simply substitute back into the equation 1 to solve for V2, and we get the value of V2 is 2.499. And our eigenvector for the first lambda is 1, negative 2.499 and 1.088. Next is for lambda 2 equal to 0, we also let V1 equal to 1. And then we have derived the equation, and then we get both of value for V2 and V3 is equal to 0. And our final eigenvector is 1, 0 and 0. Lastly, for lambda 3 equal to 12.249, we also let V1 equal to 0. And then we for lambda 1, we derive the equation again. Then we substitute back to find the V3. And for this third lambda, we get the V3 is equal to 0.11. After getting the V3, we simply substitute it back to equation 1 to solve for V2. And we get the value of V2 is 0.25308. And our final eigenvector for lambda 3 is equal to 1, 0.25308 and 0.11.
Okay, next move to the discussion. As we can see from the MATLAB validation beside, as the value of each V, we normalize it with V1 equals to 1. We need to get the value for each eigenvector by hand. For example, eigenvector 1 is 0.9640. Then we divide it by itself to normalize it to become 1. So another eigenvalue is also needed to divide with 0.9640 to get its exact eigenvector. By analyzing the value of the eigenvalue and eigenvector between the chapter 7 method of calculation and MATLAB validation, there is a slight difference between them within their decimal points, which we think that our calculation method is correct and acceptable. The value of each eigenvalue and eigenvector for our calculation is almost the same as the MATLAB validation, with almost 0.001% of average percentage relative error. So that's all for my part.
Next, Next is conclusion and recommendation. In order to show how the concept of eigenvalues and eigenvectors can be utilized to streamline the computation of simulation integration, we successfully conducted a case study by discussing 3 real-world problems that can be resolved using numerical method. The case study calculation shows that the eigenvalues are negative 12.249, 0, and 12.249. The eigenvectors are 1, negative 2.999, 1.088, 100, and 1, 0.2531, 0.11 respectively.
So this is our reference group. Thank you for this video presentation.